On this next example, notice that we have what we're saying is a probability distribution. We're trying to find out what's the missing value in the probability distribution. Well, we've got a bunch of probabilities except for one filled in. So what do we know about the probabilities? They should all add up to 1. So let's add up what we already have. Let's see what all of our probabilities that we have actually add up to. So the probabilities that we have add up to, so 0.3 we're adding up a 0.25 and another 0.25, and then we don't know the next one, a 0.05. So 0.3, 0.25, 0.25, and 0.05 add up to, let's see, we'll add up to 0.85, which means the missing probability, in order to make sure that that adds up to 1, needs to be 1 minus what we already have, which will get us that everything that's left over needs to add up to 0.15. So our missing probability here needs to be 0.15. Now that my chart, my probability distribution table is filled in, now I can answer some questions. What is the probability that exactly one tire was underinflated? Well, that can be read right off the table. Well, the probability of having only one tire underinflated was 0.25. What about the next one, the probability of having at least 2 tires? At least 2 means 2 or more, which would include what? Well, we have that 2 flat tires could be underinflated, 3 or even all 4 of them, so I'd need to add up all those probabilities. So, well, the probability of having 2 tires underinflated would be the 0.25. The probability of having 3 tires underinflated, we just found that, was 0.15. And the probability of all 4 of them being underinflated is that last value, the 0.05, for a total of, let's see, 0.45. So again, the idea with a probability distribution is to build a chart and then use that chart to answer a bunch of questions. Sometimes they'll give you the chart. Sometimes you need to figure out the values for the chart yourself. And we're going to be dealing with this kind of idea throughout all of Chapter 5. So let's take a look at one more example. On this next one, we have what we're saying might be a probability distribution. We're asking, is it? Well, first of all, the first thing I would check is, do we have any negative probabilities? Remember, probabilities need to be between 0 to 1. So we shouldn't have anything bigger than 1, and we shouldn't have anything less than 0, meaning nothing negative. And notice, if you look at the whole list, there is nothing smaller than 0 and nothing bigger than 1, so that's okay. Your second part of a probability distribution, though, is, does it add up to 1? So let's go ahead and check that. Let's add up everything. Let's add up all of our probabilities. Remember, the sigma means whatever everything is added up. That sigma is just a fancy way of saying add everything up. So let's add up all the probabilities and see what we get. Well, if you add up the 0.528, the 0.360, the 0.098, the 0.013, plus the 0.01, notice we get something that is 1.009. Now, it's not exactly 1, but it's pretty close. It's close enough. We're not getting something like 1.3 or something like 0.97. We're getting something really, really, really close to 1. So we're going to go ahead and say that's close enough. So is this a probability distribution? We'll say yes, because all of our probabilities are between 0 to 1, and it's pretty much adding up to 1 or something that would be rounding to 1. Let's take a look at another one. We've got our probability distribution in this next example that's already been built for us. We just want to answer some questions in. So the first one asks, what's the probability of getting exactly 4 sleepwalkers out of 5 adults tested? So, well, having the probability of getting exactly 4 sleepwalkers, when we look at 4 on our probability distribution and say that our probability of just getting exactly 4 is that 0.022. Now for this next one, we're asking the probability of getting 4 or more. Well, 4 or more out of 5 would mean that you could either have 4 or 5, which means, again, remember the or means we're going to be adding these up. So that means I'm going to take the probability of 4 and add it to the probability of 5. Well, let's see. The probability of selecting 4, we already said, was 0.022. Added to the probability of getting all 5, which would be 0.005. Adding those two up gets us a total of 0.027. Last question asks us to actually interpret some of our answers. Their question is 4 a significantly high number of sleepwalkers among adults? Why or why not? Use the 0.05 or 5% as the threshold for a significant event. We've used this 0.05 or 5% a lot when talking about whether or not something's usual or unusual or significant. Well, if we've got a probability for having 4 chosen as sleepwalkers of 0.022, that's about 2.2%. So is this going to be significant? No, it's not going above that 0.05 or 5% threshold. So we're going to go ahead and say this is not significant. / usual. Remember, we also use that term for the 5% or 0.05 is whether or not something was usual or unusual. So this is not going to be usual because it's below that 5% or 0.05 threshold. But that's all they're looking for.